Hello, this is Lyndon from Visionary Universe. Welcome to this brand new tutorial, and today we are going to dive a little more into the world of expressions. So today we're going to be creating a pretty cool effect. I have another example here where they're just bouncing around. Just a really interesting looking animation. But what if I told you that 0 keyframes were used for this animation? No keyframes were used. So you're wondering, how in the world are they moving? Well, we use expressions. Like I said, it's an expression tutorial, so let's go ahead and start by creating a new composition. We'll create this completely square, 1080 by 1080, and 30 frames per second. It looks good. Alright, so let's create a new solid, hit Control Y, that's the fastest way to do it, and we'll call this ball. Now it's important to remember the dimensions of the solid, alright? It's 200 by 200, because this is going to be the ball, and we have to have the perfect measurements to do the right expressions. So we're going to double click on this mask tool up here, and it's going to create a ball. Now the radius of this ball is 100 because the width is 200, so that must mean the radius is 100. So let's just remember that. So let's go ahead and start with the animation. Here's what we're going to do. Let's go to the position and separate the dimensions. Alright? Then we'll add an expression to the X position because we're going to animate the X position first. So I'm just going to type this expression, but I'm going to make another video on this channel that actually explains what the expression does. So here I'm going to type it. It's Math.acos. Let me do parentheses. Math.cos parentheses, and then we'll do time. So this creates a really interesting effect. And if you go watch that math tutorial, we're going to look at a lot of interesting stuff about this expression. So we can open up the X position parameter and enable the graph for the expression. There we go. So we zoom in a little bit, we can see that we created this zigzag, and that's perfect because it needs to bounce just like that. But it's creating very minorly. See, it only goes up to 3 pixels, or actually pi pixels to be exact. So here's what we're going to do. If we divide this by pi, so we hit slash math.pi, and so we divided this by pi. So now it goes exactly up to 1 pixel, so the peak here is 1 pixel. But what we can do is actually multiply this by the width of the composition. So the width of the composition is 1080 pixels. So let's take a look at it now before you get confused. Let's scroll out. So here we go, it's moving back and forth. It's going to hit that peak and then it's going to move back. So you can see it's moving a little bit too far, right? Because it goes all the way through the edge of the wall. But actually the anchor point is moving just perfect. Check that out. The anchor point, which is right there, the anchor point is actually moving just perfect. Look, it bounces right off the wall. And the position is judged by the anchor point. So that's what's going on. So this ball doesn't need to move quite so far. But we need to ask the question, how overly far is this ball moving? Well, it needs to stop right about here, but it keeps going. Well, how long does it keep going? Well, it goes till the radius of the circle. So we, instead of doing times 1080, which is the width of the composition, let's do 1080 minus the radius of the circle. Well, the radius of the circle is 100, so let's minus 100 from 1080, which equals 980. Alright, so there we go. So it's looking good. You can see that the ball bounces right here, just perfect. But then we got another problem. See, the ball doesn't start in the right position. We can easily fix this by adding the radius because it starts the radius too far to the left. So let's do plus the radius, which is 100, so plus 100. There we go, so it starts in the right position. But now we got one more problem. Check this out. It goes and then extends too far again since we plus 100. So that means it needs to move 100 less again. So instead of doing 980, we'll do times 880. So there we go. Now it extends perfectly, and we can go ahead and preview this. It's moving really slow, but there it goes. It goes to the very edge. So bounce. And then it'll come down here and bounce again and bounce, and it'll bounce forever. Alright, so we need to make it happen a little bit faster. So if we increase the speed of time, then it'll make everything happen faster. So we'll do time times 3. Alright, so there it's going to happen practically every 1 second. So there we go. Good. So we time times 3, and then it happens really fast. Alright, so now we need the same expression for the Y position, because it not only needs to bounce to the side, but up and down. So let's get out of the graph editor. And then we'll copy this expression, Control C, and then we'll go to the Y position, and then we'll hit Control V, then I'll paste it. So now we have the same exact expression for the Y position and the X position. So let's have a preview. There's a little problem here because everything's happened exactly the same. The Y position moves down, and it happens the same exact way with the X position. So we gotta create some variations so it bounces in a different pattern. So if we, instead of doing times 3, what if we did times 2.5 and blah blah blah? Alright? Let's make sure to do 2.5. There we go. So now it's going to do something interesting. Check this out. Here's where the real effect comes in. Boom, boom, boom. And it's doing the same exact thing, except it's taking longer for the X position to move across than it is for the Y position. So that's why it's creating that variation. So it seems as though there's a lot of complicated physics going on, but really it's just moving to the left and then to the right at different rates. we can actually take a look at the two different expressions. We'll enable both of them, and they're just different variations of zigzags, so that's why it's creating that effect. So it's a really cool animation. So we can also like duplicate this ball, so we'll hit EE to open up our expressions. EE, there we go, and then we can make some variations to the time. So instead of doing 3, we'll do 2.8, and then instead of doing 2.56, let's do 2.2. Alright, so there we go. Now it's going to create more variation. So we have 2 bouncing circles animating at different rates. So that's a really interesting effect. So the last thing I'm going to do is just kind of style this up a little bit. We'll go to gradient ramp and then drag this on the ball, and then we can change this to radial ramp. And this is actually kind of a cool way to create a spherical looking object when it's really just 2D. So there we go. Then we can blend with the original about 50%, and then it has that interesting looking effect there. So it looks more like a 3-dimensional sphere rather than just a flat disc. And we'll copy that and paste it to the other one, and perhaps the other one we can just change the color. There we go, so it looks cool. So now we have this really interesting looking animation just by those few easy expressions. Now remember, make sure and check out that math video where I explain those expressions, so that way you can be fully confident about what you've learned. It's going to go a little bit depth into the math. Maybe some people might not understand it, but you can take a go for it. Just, go there, try it out, watch the video, and see if you learn anything. But anyway, the important thing to note is that it creates a zigzag, and then we're just customizing the zigzag to fit the dimensions of the composition, so it looks like it's bouncing off the walls. So anyway, that was really interesting. I hope this video helped you guys out, and I hope you guys have fun playing around with this cool expression animation. It's fun just to look at the different patterns and everything. But mainly, I hope this video inspired your creativity to new visionary ideas. Alright, so I'd like to remind you guys to like this video if that's no problem, and consider subscribing. It's been fun, guys. This is Lyndon, and I hope to see you in future videos from Visionary Universe.